Alright, so here we have my second example of solving first order linear differential equations. And I'm going to kind of run through the procedure and everything in this video. I went through it in the first video. So a first order linear differential equation is an equation of the form dy dx plus p of xy equals f of x. And p and f are continuous functions. And this differential equation, this first order linear differential equation, is in standard form. Okay, and also, the dy dx, you may see it written as y prime also. So you could have the dy dx, or you could have, instead of this, it would be written y prime plus p of xy equals f of x. Alright, so let's go ahead and look at how we solve this thing. So to solve it, we want to first put it in the standard form, that form that we just looked at. And then we need to identify p of x and find the integrating factor. Well, p of x is this, p of x is in front of y. Okay, once you get it into standard form, that would be p of x. And then to find the integrating factor, that would be e raised to the integral p of x dx. Okay, and then we multiply the equation from step 1 by the integrating factor. So this equation here gets multiplied by our integrating factor, which is this e raised to the integral p of x dx. Alright, and then we have the left side of the equation in this step. So this left hand side here is the derivative of the product of the integrating factor and the dependent variable y. So it's the integrating factor times y. If we take the derivative of that, we'll get this left hand side of the equation. Okay, and then we just integrate both sides of the equation from step 4. Let me go ahead and erase that. So let's go ahead and look at this second example. So we have y prime minus y times tangent x equals 1, and x is between negative pi over 2 and pi over 2. Alright, so you can see this is already in standard form. Okay, so I have a coefficient of 1 in front of y prime. So I need to get p of x. So p of x is the term with the y. So in this problem, I can see that p of x is equal to negative tangent x. Okay, so I have identified my p of x, and now I need to find my integrating factor. Now remember, your integrating factor is e raised to the integral p of x dx. So what I'm going to do here is I'm going to take just this part of it and I'm going to evaluate this integral here. Okay, so I have the integral of p of x dx is equal to negative integral of tangent x dx. I'm going to put the negative sign outside the integral symbol. Alright, and this would equal, you remember what this is? That's the natural log absolute value cosine x. Okay, remember this, let me just show you this real quick. This is negative integral, tangent is sine x over cosine x dx. Okay, and And remember, well, what we can do if we're going to do this, we can take this negative and bring it inside, and we know that the derivative of cosine is negative sine, and so that's where we would get natural log cosine x. Okay, because if we take the denominator, the derivative of the denominator is in the numerator, so that tells us natural log. Alright, so let's look at what we have. So that is going to give me e raised to the integral p of x dx, which is equal to e raised to the, and then this, see the integral px dx, that's just natural log absolute value cosine x. So here's my integrating factor. Okay, that's my integrating factor. Alright, so once I find my integrating factor, what did the next step tell me to do? Well, let's look at it. So we identified p of x and we found our integrating factor. So now I have to multiply the equation from step 1, okay, and that's the differential equation in standard form. So the differential equation in standard form, I multiply that by my integrating factor. Okay, so let's do that. Alright, so here's my equation. So I have y prime minus y times tangent x equals 1, and I'm multiplying that times my integrating factor. So I'm going to multiply it by cosine x. Alright, so maybe you're wondering where the absolute value symbols went. Okay, so where did my absolute value symbols go? Okay, well, and I'm sorry, let me do a little bit more here. Okay, you see how I got my, this is my integrating factor, but I didn't simplify it enough. I mean, I did here, but alright, you see how this is the same, this e here is the same as the base of this log. Remember, natural log is understood to be base e, and so that would be natural log cosine x, my integrating factor. Sorry about that. Alright, so I'm going to multiply the standard form of the differential equation by my integrating factor. Alright, so what happened to the absolute value symbols? Where did that go? Well, if I look at the problem, you see this? It tells me that x is between negative pi over 2 and pi over 2. Alright, so let's come over here real quick. Here's pi over 2. Here's negative pi over 2. And remember, you got first, second, third, and fourth quadrant. So you can see that I'm here. I'm in the first and fourth quadrant, and cosine's always positive. So I don't need my absolute value symbols here, because I know that since x is here and here, well, cosine x is positive. So that's why I can get rid of those absolute value symbols. Alright. Alright, so when I multiply this through, I'm going to get y prime cosine x minus y tangent x times cosine x equals cosine x. Alright, and this is going to give me y prime times cosine x minus y times, now let's look at this, tangent x times cosine x. Well, that's just sine x equals cosine x. Okay, so did we see where the sine x comes from? Well, tangent x times cosine x, well, tangent x is sine over cosine times cosine, and the cosines cancel. And so that's why we're just left with sine here. Alright. Alright, so I multiplied the standard form by the integrating factor. Okay, so the standard form of the equation times the integrating factor. Now, remember, once I've done that, then the left-hand side of this equation in step 3 is the derivative of the product of the integrating factor and the dependent variable y. Alright, so that is going to give me the now let me change colors back. So that's going to give me the derivative of the integrating factor, which is cosine x. See, there's my integrating factor, cosine x, and the dependent variable y. Okay, and I'm going to go ahead and write the y in front. And that equals cosine x. Alright, so let me show you how that works. The see this right here, if we take the derivative of this, okay, if you take the derivative of this, this is the product rule. So it's the derivative of this, which is y prime, times the second function, cosine x, plus the derivative of the second function, which is derivative of cosine is negative sine, times the first function, y. And so that would give me y prime cosine x, and then that would give me minus y sine x. So you see, when I took the derivative of this, I ended up with this right here. Okay. Alright, so now it just tells me to do what? Remember the last step? Integrate both sides of the equation found in step 4. So I need to integrate both sides. Okay, so I'll integrate this and integrate this. Alright, so integrating the left hand side, that's just going to give me what? Y cosine x equals, and then I integrate cosine x, that's going to give me sine x. Okay, and these integrals are with respect to x. Okay, alright, and so that's going to be sine x plus c. Okay, and now I solve for y, so I'll divide everything by cosine x, and so that's going to give me y equals, and then sine over cosine, that's tangent x, and then this term here, that's the same thing as c times 1 over cosine x, so I'll write that as plus c times secant x, and this would be my solution. Alright, so I hope this video's helped. I may post a couple more on first order linear differential equations, but this is my second video. I hope it helped, and if you like it, you can check out my other videos. Alright, thanks.